Hello, I'm Victor Chen, founder of GoPeaks Initiative, an applied research initiative to integrate fragmented expertise into responsible decision tools. Today, let me give you a demo of a new beta version of XKEP, which stands for Expert Knowledge Exchange Platform. The idea of XKEP is to create a shared knowledge base where users can teach and learn expert knowledge from a single platform. The knowledge base is hosting and accumulating a unified knowledge graph from its users, which visually represents nodes and the links between the nodes. Here, nodes represent real-world concepts, and links represent the logical relationships between them, such as in this demo, taxonomic and causal associations. Now, users can open a local shell and launch the Python script to load the knowledge base. It will first check whether all the necessary packages have been installed in this local machine. If not, it will automatically install and upgrade the necessary packages, and then ask for the user ID and the password to load the knowledge base from the cloud. And in this demo, we use Neo4j Aura database services. Now, it's asking whether you are an expert user or a regular user. And an expert user will be allowed to use advanced Cypher query language to interact with the knowledge base behind. Now, let's assume we are just regular users. So enter no. So first, it's asking if you'd like to see a summary of the knowledge inside the XKEP that you have loaded. Yes. All right, so it's counting the number of links, which is the unit of expert knowledge in this knowledge base. And we can see right now it has already 2,428 units of expert knowledge inside. We can also see a structure in terms of what concepts, real-world entities concepts have been included in this knowledge base. Now, once it's done, we can enter 3 to skip. All right, so it's loading a list of the standardized names of the concepts in the current knowledge base for this demo purposes. It's not asking whether you identify yourself as a teacher or learner of this knowledge base. So let's assume that we want to teach something. Okay, we're a teacher. All right, so let's teach something new. Yes, 1. Enter the name of your team. Let's call us testing team testing. Specify the level 1 label of node 1. As I mentioned, each node is a real-world entity or concept, and we use multiple levels to label the taxonomies of each concept. So it could be organized in a relatively structured format in this knowledge base. And we have curators to manage the taxonomies inside the knowledge base. So let's, again, just for simple purposes, let's call testing level 1. Testing node 1, level 1. Okay. Level 2 would be testing node 1, level 2. Name of the node testing node 1. And how to measure this node? Testing node 1 measure. Specify the level 1 label for node 2. So the second concept you would like to introduce to describe a relationship to represent the knowledge you are going to teach. Say testing node 2, level 1, testing node 2, level 2, testing node 2, testing node 2, measure. And what's the relationship between them in terms of the direction of influence? Let's say it's positive, testing positive. So later when we look for something, we know this is a testing knowledge unit. It's not a real knowledge inside. Sample size, testing size, testing, what's the industry, testing industry, sample country, testing country, source of knowledge, testing source. Provide a unique reference code for this entry. Now, this is important because this allows you to access and modify this particular unit in this eXpert knowledge base in the future. Say testing 1, 2, 3. Would you like to review this entry? Yes. Okay, so we've entered a unit of knowledge graph into this knowledge base, including multiple levels of labels for 2 real-world concepts, as well as some descriptions of their relationships. Now, it's asking, would you like to undo this entry? Obviously, we want to undo this because this is really not a high quality, meaningful real knowledge. Let's undo this entry 1. Okay, now let's teach something new. Suppose we are done. So let's move on. No. Okay. Now it's asking if we would like to learn something from this knowledge base. And it's asking how many concepts, how many real-world entities we have decided on our mind. Let's assume we already know the research question, and we want to understand the relationship between 2 particular concepts from the knowledge base. Let's enter 2. Okay, so it's asking what's the first concept you are interested in. Let's say job satisfaction. And the second is performance. Okay, we want to understand how someone's job satisfaction might influence its performance. Okay, would you like to see all names under your first concept? Yes. Okay, job satisfaction. Okay, it's called job satisfaction uniformly in this knowledge base. And how it's measured? Yes, for 1. Okay, it's measured in several ways, and it's also listing the number of knowledge units for each measurement. For taxonomy, we can skip that for now. Would you like to see all names under the second concept, performance? Let's say yes. Okay, it's sometimes called a job performance, sometimes called engaging in OCB. Would you like to see all measures? Yes. Okay, those are the measures people used to describe job performance. Taxonomy, let's skip. Would you like to see a summary of all knowledge related to these 2 concepts? Let's say yes. Okay, there are 16 knowledge units. Would you like to see a report of all the knowledge? Yes. And I guess this is going to be a large table. Right, so it's showing the names of the 2 concepts, the measures for each, as well as the direction of the influences between them, and also the sample context in which the knowledge was created in terms of sample industries, countries, and also the publication source of each knowledge unit. Now, would you like to see names of the teacher team for all the knowledges? Yes. So this is showing the names of the experts who created all the knowledge units reported above, because this is from a subsample, a modified subsample of working paper I'm working on with several of my co-authors. So it's listing the names of me and my co-authors. Would you like to see the relationship between these two concepts? Yes, see all the relationships. It's split between positive and negative. So it's really a inconclusive area of understanding. We'd like to see the sample characteristics. We can skip that for now, but you get idea. We can see the underlying sample contexts in which this expert knowledge was created. Let's skip that by entering 4, none. Okay, would you like to learn more? Let's say, yes, I'm done. 2. Okay, so here's something interesting. XKEP can assist you to build a causal diagram based on domain expertise. When people analyze the causal influence between two concepts, for example, a data science team wants to conduct a causal inference analysis, they need to draw the expert opinions or expert assumptions from either their own research or from a domain expertise knowledge base to draw a causal diagram in order to find the confounders as well as the instrumental variables for them to develop the causal model to make causal inference. And this knowledge base can be used for that purpose. So it's asking, would you like to build a causal diagram? Yes, let's try. Let's enter 1. Okay, let's try the 2 concepts we have just learned. So the first concept is job satisfaction. The second concept interested in is performance. Let's see if they have any confounders or instrumental variables for to assist us to build a causal diagram for causal inference analysis. Okay, now show results. Let's see all the confounders. 1. Oh, actually, there are 2 confounders. So one is eudaimonic well-being, and second is perceived politics. Let's see instrumental variables. Oh, there's so many choices, but you get idea. I'm not going to see all of them. Let's skip. Suppose we are done. Okay, your graphs are ready. Please open a Jupyter notebook to display them. This is the fun part. So now we can open a Jupyter notebook and to actually visualize the causal diagrams we have just built and loaded. So the first, let's see all the confounders given X and Y. And X in our search is job satisfaction, and Y is performance. All right, so now, as we can see, job satisfaction is causing job performance, but they are both caused by two confounders, perceived politics and eudaimonic well-being. So this will help us build our causal models to control for the backdoors of those two by controlling those two confounders to make causal inference analysis. Second, let's visualize the causal diagram of the instrumental variables of X given Y. This will take a bit longer because there are a lot more variables. Okay, so job satisfaction is the independent variables, and we're looking for instrumental variables. That is the variables which will affect job satisfaction, but not the outcome variable we're interested in, which is performance. Right, as you can see, performance is not linked to any of those variables. Okay, so this is a beta version of XKEP, just demonstrating the idea of a shared platform where users can teach and learn on the same on a single source of knowledge base. And this is one small step at GoPeaks to develop a shared brain idea where users, citizens can teach and learn from the same place.